My name is Neal. I'm an aerospace engineer here at NASA Langley Research Center. I work in the Hypersonic Air-Breathing Propulsion branch, where we work on the technology and development of scramjet engines for global reach and access to space. I got involved with NASA as a graduate student. One of my fellow graduate students was working on a NASA project, and he and I began working together on this project. And before I knew it, I was working out at NASA Dryden Flight Research Center. I've worked with a myriad of flight test experiments, everything from the subsonic stuff to the supersonic to the hypersonic. In particular, in the subsonic stuff, I've worked with solar-powered, hydrogen fuel cell-powered large winged vehicle bodies. In the supersonic, I've worked with all the fighter jets, F-16s, 15s, 18s, you name it. I've touched them all. And then also worked on the B-52 with lifting bodies and things like that. But my most memorable experiences are working with the fastest manned aircraft, the SR-71 Blackbird, where we did flight test experiments and rocket experiments on that vehicle. Also worked on the HyperX scramjet flight test demonstrator, which was the first autonomous hypersonic powered scramjet powered vehicle to travel out to Mach 10. And then recently we've been working some new technologies with inflatable reentry vehicles to find new ways to bring payloads back from the International Space Station. Probably the most exciting aspects of my job are that I never know what to expect from day to day. I have to be creative on a day-to-day basis with how I come about solving the technological challenges associated with my job. The environments of a hypersonic flow field are very challenging, it's very volatile, and so we have to be creative about how we develop and do the test and engineering of these types of engines. Of all the subjects that I learned in school, my job is basically a marriage of all of them. The science and math give me the skills to understand and model the physical phenomena associated with hypersonic flow and high-speed entry and things like that. But of course, that is not enough. We have to be able to do communications, and that requires English and writing and that kind of stuff, because we have to be able to communicate what we've learned in those tasks and pass that information along to the community, not only the technical community, but also to, of course, the educational community, to get that information out and inspire the youth to seek out and pursue careers in science and technology.